90% of the world's data being created in the last 2 years has an energy cost to it. This is going to become even more and more severe with artificial intelligence. Turns out that the dirty little secret in all of surface chemistry is that actually a lot of the time, the stuff that does the chemistry on surfaces in a fuel cell, in an electrolyzer, in your catalytic converter, are the defect. But defects are really difficult to control. It's easy to draw a perfect structure. It's very difficult to get a perfect structure. But what is maybe more difficult than that is to say, okay, I'm going to have an imperfect structure exactly the way I want it. What we discovered is by twisting these layers, the same kind of effect that at very low temperatures leads to superconductivity can be used to create effectively tunable defects, so that where the electrons like to sit in these twisted structures can be controlled by twist, whereas they usually are controlled or ill-controlled by defects on regular surfaces. What we see is that we can control the rate at which the chemistry is taking place by controlling the angle between these graphene layers. Simply, you take the same material and you just twist it, and at different angles, it behaves chemically completely differently at one angle versus another. Typically, when you want to switch the magnetic properties of a material, you need about 1,000,000 amps per square centimeter in basically all conventional magnetic systems. These materials that I've shown you, they require 2 orders of magnitude lower current to switch. And it's very sharp and very reproducible to design magnetic, so-called spintronic material that lead to this really low power, low energy cost switching between various states.